Hello everyone, my name is Vimal Raj. I'm a lecturer from Mechanical Department from GEMS Polytechnic College, Aurangabad, Bihar. So today we're going to see the unit number 3, which is water pollution, from the subject Environmental and Pollution Control 1625503 according to the SPT syllabus. So today we're going to discuss about the biological oxygen demand, that is BOD. So the that we're gonna discuss for today would be biological oxygen demand, BOD, COD, that is chemical oxygen demand, and TOD is total oxygen demand, and acidity and alkalinity. So the biological oxygen demand, the extent of organic matter present in water sample can be estimated by supplying oxygen to this sample and finding the oxygen consumed by the organic matter present in water. So this oxygen demand is known as biological oxygen demand, BOD. So the extent of organic matter present in the water sample, the extent of organic matter, that is the content, the organic content that is present in the water, which water sample, can be estimated by supplying oxygen to the sample and finding the oxygen consumed by the organic matter present in the water. Basically, to find how much organic substances are there in the water. So how they will do the test is, they will keep the water sample and they will give some oxygen to that water, so that how much oxygen is being eaten or taken by the organic substance that present in the water. So if it is taking about 50% of oxygen, then it shows that 50% of organic substance are present in the water. So likewise, they will do this test in order to find the level of organic materials are there in the water. So this oxygen demand is known as the biological oxygen demand. So basically, when these organic substances are present in the water, what happens in, because we need oxygen for the aquatic animals to live in the water, right? Basically, water has the oxygen. So basically, this water gives the oxygen to the aquatic creatures. So what if this water has been polluted? When the water has been polluted, basically it has been polluted with some organic substances, toxic chemicals, such like that. So when these chemicals has been introduced to this water bodies, what happens is, these this organic materials or this organic substances that is present in the water will be eating the oxygen. So once they start to eat this oxygen, when they start to consume the oxygen, these aquatic creatures that lives in the water will be having a big demand for oxygen. So that leads to dying of the aquatic creatures. So that is called the biological oxygen demand. So it is not practically possible to determine the ultimate oxygen demand. Hence, BOD of water during the first 5 days at sea is generally taken as a standard demand. So basically, when they do this test, ultimately they cannot find the whole amount of oxygen demand is happening. But hence, when they do this biological oxygen demand testing for the first 5 days, they will just grade it with the sea. So generally that shows the standard. So that is BOD 5 is equal to BOD of 5 days. So loss of oxygen is milligram per liter into this dilution factor. So with this only they will calculate the biological demand of oxygen. So when they do this test, that is how much oxygen is being lost and how much dilution factor is added. I mean, when they do this test, they will check with the loss of oxygen in milligram per liter with the dilution factor. So how much water they use it and how much oxygen they use it. So when they multiply it, they get the biological oxygen demand. So the biological oxygen for safe drinking water must be nil. So the BOD of safe drinking water must be nil. So what is the biochemical oxygen demand or BOD? So healthy water, unhealthy water. So that shows the thing, because when the biological oxygen demand happens in the water, as I said, the creature that is living inside the water will be in a trouble wherein which it cannot survive, because the oxygen content that is present in the thing will be very less. So because of that, what happens is the animals will tend to die. and that is a major impact on the aquatic creatures. So this picture clearly shows us this is the healthy water and this is unhealthy water. So healthy water has oxygen and unhealthy water doesn't have the oxygen content, because these organic matter that is present in the water will start to eat the oxygens that is present in the water. COD, that is a chemical oxygen demand. So the chemical oxygen demand, COD, is a measure of water and wastewater quality. The COD test is often used to monitor water treatment plant efficiency. This test is based on the fact that a strong oxidizing agent under an acidic condition can fully oxidize almost any organic compound to carbon dioxide. The COD is the amount of oxygen consumed to chemically oxidizing organic water contaminations to inorganic end products. So chemical oxygen demand is nothing but is a measure of water and the wastewater quality. So basically they will do this test in order to find the quality check for the wastewater water. So TS So this test is purely based on the fact that a strong oxidizing agent under the acidic condition they will use in order to oxidize almost any organic compound to the carbon dioxide. They use this oxidizing agent in order to oxidize the organic compound. So that COD is the amount of oxygen consumed to chemical oxidizing organic water contamination to inorganic end products. So basically when they introduce this organic substance, the oxidizing substances, they will tend to check that how much oxygen is being oxidized using this chemical formulations. The COD is often measured using a strong oxygen like potassium dichromate, potassium iodate, or potassium permanganate. So they use this oxidizing agents in order to do this COD test. So under acidic condition, so they always do this in the acidic condition where the level of thing will be lesser than 7. Yes, it will be more than 7. So a known excess amount of oxidant is added to the sample. Once oxidation is complete, the concentration of organic in the sample is calculated by measuring the amount of oxidant remaining in the solution. This is usually done by titration using an indicator solution. So basically this process is done using the titration process. We might have done this titration process during our first year in college, as well as in our 11th and 12th standard. We used to do this titration test, and also they will be diluting acid with the with the oxidizing agent, right? So this is usually done by the titration method. So they used to do this titration test for the calculation of chemical oxygen demand in the water. So it is expressed by mg. So it is also expressed in milligram per liter, so which indicates the mass of the oxygen consumed per liter of solution. So they use this oxidizing agent, chemical agent, to find out the quality of water. So COD test only requires 2 to 3 hours. So basically we always know that whenever we do this titration test, it only requires some amount, some minimum amount of time for the titration works to be done. So we used to do this titration work only, maybe in an hour we'll do this. So while this biochemical or the biological oxygen demand BOD test requires 5 days. So in order to this BOD test, it requires 5 days, but COD test is very easy because it takes only 2 to 3 hours. So for BOD it takes 5 hours because they used to do the calculation of this oxygen. How many organic substance is taking this oxygen from the water. So it requires minimum 5 days of test, but in the COD it requires only 2 to 3 hours. So it measures all organic contamination, including those that are not biodegradable. Even it also checks that the chemical substance, organic contamination that's present in the water, whichever thing, even it is a biodegradable also, it will be able to find it out. So there is a relation between BOD and COD for each specific sample. So but it must be established empirically. COD test results can then be used to estimate the BOD of a given sample. So unlike for the BOD test, toxic compounds such as heavy metals and cyanides in the sample to be analyzed do not have an effect on the oxidants used in the COD test. Therefore the COD test can be used to measure the strength of waste that are too toxic for the BOD test. So some organic molecules like benzene and pyridine are relatively resistant to dichromate oxidation and may give a falsely low COD. So basically when they do this test with this kind of benzene and pyridine, relatively it has a more resistance or relative resistance to the dichromate oxidation, and may give a falsely low CODs, which is very which will not give an exact result, because when you use this kind of heavy strength, when they use this heavy two toxic materials, when they use this two toxic materials, it automatically it will not give the exact COD. So the chemical oxidation demand, so they have to do this, oxygen consumption measure. So they use this method to find it out how much oxygen has been consumed when they do this test. So they have to check the quality of water. Basically the quality of water is very important, because for BOD it takes 5 days, but for COD it takes only 2 to 3 hours. So even it will show the any organic substances that is which is biodegradable also we can easily find with this thing, because this chemical, when they use this titration setup, they can easily titrate, and they can show the value that how much organic substance are present in the water. So that is an easy method which we can get the result within 2 to 3 hours. Next one is total oxygen demand. So according to its name, this parameter defines the total oxygen demand of water sample. So it is based on the same principle as the COD. Correspondingly, this parameter has existed already for 40 years. However, it fell into oblivion in Germany. In contrast, the parameter TOD has been standardized as a reference parameter for the assessment of organic pollution in water in the US. So to define the TOD, the sample is thermally oxidized in an oven, and the emerging oxygen is measured directly in the carrier gas by NDIR detector. The TOD value can be affected by inorganic compounds. However, these influences are generally very small, and thus enables a mathematical compensation. The parameter is particularly suited for the correlations with COD and BOD, since inorganic carbons do not affect the correlation, and the non-carbonaceous BOD nitrogen compounds are also considered. Due to the similarities of the determination of the TOC, the TOD is well suited for online monitoring. So according to this, this parameter is the total oxygen demand, that is how much total oxygen is demanded in the water. So it is already been existed already for 40 years, and this is a old ways of method in order to assess the organic pollution in the water. So they used to do the total organic substances that is present, total oxygen demand, how much oxygen is being demanded in that particular sample of water. So they will do this check before, but nowadays after this BOD and COD came into place, this TOD was been existed, because it is something, the parameter is situated correlation with the COD and BOD, since the inorganic carbons do not affect the correlation, because some chemicals that is when they use this inorganic compounds, it might not react properly. So for that reason, they made it to happen. They made it like this. So this total oxygen demand has been neglected, and TOD has been totally totally existed. Acidity and alkalinity. So acidity level in water waste indicates its corrosive properties, and can take a leading role in the regulating biological process as well as in chemical reaction, such as chemical coagulations and flocculations. Alkalinity too contributes to the property of wastewater, many of which also affects biological processes such as nitrification and chemical reaction. So we already discussed about this acidity and alkalinity, because acidity and alkalinity is very important factor, wherein which if you see it, if the water is too acidity, it is not consumable, it is not good to be consumed, or if the water is too alkalinity, it is not good, because both is having a chemical property which is such as a chemical coagulations and flocculations will happen. So basically this the acidity and alkalinity happens. So just let me tell you what is about coagulation. Coagulation is also known as clotting. So it's a process by which a liquid changes to a gel format. So forming a clot, it potentially results in the hemostats, that the cessation of the loss, a damaged vessel. So basically the coagulation is nothing but from the liquid form to gel form. It is transforming it to from a liquid form to a jelly substance, that is called the coagulations. And the flocculation is nothing but the particle which is floating on the like a clump together, wherein which it's some things, organic substances, that is like floating on top of the water. So in colloidal chemistry, like flocculation refers to the process by which fine particulates are caused to clump together into a flock. The flock may then float to the top of the liquid, settle on the bottom of the liquid sedimentation, or be readily filtered from the liquid. So basically this thing is, something will be floating on top of the liquid water and something will be filtered and will be go into the bottom of the liquid. So when we do the filtration, sedimentation happens. So this is the acidity and alkalinity. Next, in alkalinity is the measure of solution capacity to react with a strong acid, usually sulfuric acid, H2SO4. They use this to a predetermined pH value. So in order to find the alkalinity, they use this sulfuric acid to determine the pH value. So the alkalinity of a solution is usually made up of carbonate, bicarbonate and hydroxide. Similar to acidity, the higher the alkalinity is, the more neutralizing agent is needed to counteract. So in general, a treatment plant and its collection system operates better with wastewater, lower in acidity and higher in alkalinity. So basically the collection system operates better with the wastewater, lower in acidity and higher in alkalinity. So this is a example of the pH chart, where in which you can see it, 3%, 4% and 5% shows that, for 5.0% shows that this is acidic in nature, which is bad, like sodas. These are acidic things, and bottled water have this, it's not good. And average tap water could range from 5 to 7, which is a neutral, and from alkaline 8, 9, 10 it goes to ideal, like Syrah water and natural spring water, which has the alkaline in nature. So this is a picture that shows you that acidic and alkaline nature. So people who used to drink a lot of Coke, sodas, things, please make sure that you avoid those things, because these things have this acidic property. They have this acid which is literally they can burn your intestine. Basically, whenever you drink this acid content like sodas or Coke or Miranda, something like that, when you drink, you start to have, you start to crave for food. That is, hunger will start. You will be starving for food. Why? In the sense, the acidic that is present in that liquid, which will be reacting to our the liquid, that is acidic liquid in our stomach, so which cause a hole in the intestine. The small holes can be enlarged, and which results in the ulcer and all. So what is the correct way? We have to drink the neutral water, so it should be from 6 to 7. So that's a neutral water, so we can use it, tap water. So based on the region and area we can solubly, we can isolate, and we can you can use the filtration process, and we can use it, and we can drink those waters. Goes for alkaline also is not good. It's not recommendable, because the Sierra water, all those things, the battery water thing, they use this thing, other things, distilled water, now they have this alkaline nature, so which is not recommendable and which is not good for a drinking purpose. So that is the difference between the acidity and alkalinity. And the coagulation is nothing but the clotting of the water, that is like clotting of blood. That's the coagulation. Such as chemical coagulation, that means something, clotting of the chemical happens. And flocculation nothing but the clumps which makes as a flock, and which is literally on the top of the water content, and some of the things will be sedimented and goes to the bottom. So with that, we have come to the conclusion for this summary. So in detail study of biological oxygen demand, we did it, and COD, chemical oxygen demand, we did it, and the TOD, total oxygen demand, we did it, and acidity and alkalinity. So these are the reference book. So if you have any doubts, you can go and you can refer these books. So with this, we have come to the conclusion for the lecture number 11, biological oxygen demand. So we will see the next topic in the next PPT. Thank you for watching this video. Thank you so much.